Welcome to everyone. In this video, we're going to discuss about DSB-SC. So, DSB-SC means double sideband suppressed carrier. It is a part of an amplitude modulation. Here, there are two sidebands and the carrier is suppressed. Whereas in amplitude modulation, or we can call as double sideband transmitted carrier, the carrier is also been transmitted along with both the sideband. But after double sideband transmitted carrier, an upgrade version, that is double sideband suppressed carrier, has been introduced. Here about 66% of power can be saved. Now we can say why power can be saved and how power can be saved. Because the carrier signal is suppressed, only the two sideband, that is upper sideband and the lower sideband, is transmitted. So the formation is done only for the USB and LSB. That's why the power can be saved, as we are not transmitting the carrier component. Let us see the definition first. So, if the carrier component of the amplitude modulation is suppressed and only the two sidebands are transmitted, this modulation is known as double sideband suppressed carrier. So from this presentation we can see an figure. From this figure we have a double sideband full carrier, or we can call it as double sideband transmitted carrier. Here there are three components. We have left side, we have a lower sideband, right side and upper sideband, and the middle portion is a carrier component. So here the transmission is done for all the component. So here the transmission is full transmission is happening, therefore 2/3 of the power has been wasted in carrier, which carries no information. So what we can do in double sideband suppressed carrier, see this figure. So from the figure we can see, so here carrier is been suppressed and the sidebands, that is LSB and USB, are allowed for the transmission. Now let's see the expression of DSB-SC. So first, it is similar as double sideband transmitted carrier. So first is modulating signal M of t, that is AM cos 2 pi FM of t. Then the carrier signal C of t, AC cos 2 pi FCT, where AM is the amplitude of the message signal or modulating signal and AC is the amplitude of carrier signal. FM is the modulating frequency, FC is the carrier frequency. Okay, now the equation is what for after modulation. So S of t is the modulated signal equation of DSB-SC. So that is M of t into C of t. So M of t into C of t, if you put the value, so we are getting S of t equal to AM AC cos 2 pi FM of t into cos 2 pi FCT. So that is the equation for double sideband suppressed carrier wave. Now see the bandwidth of DSB-SC wave. So here bandwidth equal to what? Maximum frequency minus minimum frequency. So consider if the equation is S of t is the double sideband suppressed carrier. So after putting the value, so we are at last we are getting S of t equal to AM into AC by 2 cos 2 pi FC plus fm of t plus am AC by 2 cos 2 by fc minus fm of t. So here the two frequency are available. So that is fc plus fm, that is called as USB section or USB component, and the next is fc minus fm of t, this is the LSB component. So here, so maximum frequency is how much? That is fc plus fm, that is the maximum frequency, and the minimum frequency is fc minus fm. So the maximum frequency and minimum frequency we got. Now we can find out the bandwidth. So bandwidth will be how much? It will be twice of fm. So bandwidth is twice of fm. So from this we can say the bandwidth of double sideband suppressed carrier and the bandwidth of double sideband transmitted carrier are equal. Now we'll see the power calculation of double sideband suppressed carrier. So we have the equation of double sideband suppressed carrier. Okay, now we know the total power. Total power of DSB-SC is PUSB plus PLSB. We are not using PC. Why? Because PC has been suppressed. So after putting the value of P, we are getting the value of PUSB as AM square into AC square divided by 8R. So similarly we are also getting PLSB, AM square into AC square by 2R. Now if you put the value in the equation of PT equal to PUSB and plus PLSB, so we are getting AM square into AC square divided by 4R. So this is the equation, or this is the value of total power of double sideband suppressed carrier, which is required power for transmitting the signal of DSB-SC. So now we're going to see about the DSB-SC modulator, that is double sideband suppressed carrier modulators. So generally there are two types of modulator in double sideband suppressed carrier wave. Number one is balanced modulator and number two is ring modulator. So let's see the first one, that is balanced modulator with the block diagram. So here we have two AM modulator, two numbers of AM modulator, and then we have one summer and we have one local oscillator. So from this diagram we can say we are giving the message signal. We are giving the message signal to the upper amplitude modulator, AM modulator, and the negative of message signal will be given to the lower AM modulator, and the carrier signal is given to both the modulator, that is upper AM modulator and lower AM modulator, with C of t, that is AC cos 2 pi FCT. So that carrier signal is common to both the modulator. Now after the modulation of both the upper and lower, so the output is coming as S1 of t and S2 of t. So S1 of t is the product of M of t and C of t, and S2 of t is the product of minus M of t into C of t. Then these two signal S1 of t and S2 of t will be added in the summer, and finally we are getting the value, that is S of t. Now just see the derivation and the explanation here. So here the balanced modulator consists of two identical AM modulator, as I said. So these two modulators are arranged in a balanced configuration in order to suppress the carrier. So that's why it is called balanced modulator. Now the same carrier signal, that is C of t equal to AC cos 2 pi FCT, is applied to one of the inputs of these two AM modulator. Next, the AM, that is the message signal or modulating signal M of t, is applied as another input to the upper AM modulator, whereas the M of t with opposite polarity, that is called minus M of t, is applied to the lower AM modulator. Now at last we are getting the two number of value, that is S1 of t and S2 of t. So S1 of t is AC into 1 plus Ka M of t into cos 2 pi fct, and the output of lower AM modulator is S2 of t equal to AC into 1 minus Km M of t into cos 2 pi fct. So here this S1 of t and this S2 of t will be added, okay, added through a summer block or summer section. Then we are getting the value of S1 of t minus S2 of t. Why? Because S1 is giving as a positive sign and S2 of t is given as a negative sign. So at last we are putting the value of in S of t, then we are getting this value, that is AC cos 2 pi fct plus AC Km M of t into cos 2 pi fct minus AC cos 2 pi fct plus AC into Km M of t into cos 2 pi fct. So from this equation at last we are getting S of t equal to 2 AC Ka M of t cos 2 pi fct. So the final standard equation for double sideband suppressed carrier for balanced modulator is S of t into S of t equal to AC M of t cos 2 pi fct, where we have removed the constant term which is called scaling factor, that is 2 Ka is known as scaling factor. So at last we are getting S of t equal to AC M of t cos 2 pi fct. That is the equation for double sideband suppressed carrier for balanced modulator. Next we will going to see about ring modulator. So this is the block diagram or the circuit diagram of ring modulator. So here we have 4 number of diodes, that is D1, D2, D3 and D4, which are connected in the as a ring structure. So that's why it is called as ring modulator. 2 center tap transformer are used. One is initially and at the end also we are using. Whereas the carrier signal is applied between the 2 center tap transformer. From the diagram we can see the below of the circuit diagram we are applying the C of t, that is carrier signal. Now for positive half cycle of the carrier signal, now the carrier signal when you are giving during the positive half cycle, what will happen? So the diode D1 and D3 will be switched on and the other diodes, that is D2 and D4, are switched off. So in this case message signal is multiplied by +1, that is positive, and for the negative half cycle of the carrier signal, so in this condition D2 and D4 will be in switched on and D1 and D3 are switched off. In this case message signal is multiplied by -1, therefore the result will be in 180-degree phase shift in the resulting double sideband suppressed carrier wave. So here the explanation and the operation is given. So finally what we are getting? We are getting the value of S of t. So S of t will be 4 by pi summation n equal to 1 to infinity minus 1 to the power n minus 1 by 2n minus 1 into cos 2 pi fct into 2n minus 1 into m of t. So this is the equation represents the double sideband suppressed carrier of ring modulator, which is obtained as at the output transformer of the ring modulator. DSB-SC modulator are also called product modulator as they produce the output which is the product of two input signal. One is message signal, one is carrier signal. So these are all about the two types of double sideband suppressed carrier modulators. So next we will see about the double sideband suppressed carrier demodulator. So here first of all we will see the definition for demodulation. So the definition is what? The process of extracting an original message signal from the double sideband suppressed carrier wave is known as detection or demodulation. It means what? The output of the demodulation or the demodulator is message signal, that is the original signal. So from where we are getting the message signal? From the modulated signal, that is double sideband suppressed carrier wave. So for demodulation of double sideband suppressed carrier, we can say these are of two types. Number one is coherent detector and number two is Costas loop. So first we will see about the coherent detector. So here coherent is what? Here the same carrier signal which is used for modulation is used to detect the message signal. Why here the process is called detection of detection? This is called coherent or synchronous detection. Why? Because the same carrier signal or the carrier frequency is used for modulation as well as demodulation. Okay, now see the block diagram here. Product modulator we are using. Now this product modulator we are giving an input of S of t, that is DSB-SC wave, and also we are giving the local oscillator signal, that is C of t. Okay, so here the carrier signal will be differ from the modulator carrier signal within phi degree. Okay, so after product modulator we are product modulation we are getting the voltage of V of t, the signal. Then this signal will be passed through the low pass filter to remove the higher frequency signal, and it will allow only the message signal, that is the low frequency signal, that is the V naught of t, which is the demodulated output. So see here the expression S of t AC cos 2 pi fct m of t. The output of the local oscillator is C of t, that is the carrier signal also. So this is AC cos 2 pi fct. Addition we are using plus phi. So phi is the phase difference between the local oscillator signal and the carrier signal. So at last we are getting V of t, that is S of t into C of t. So putting the value here, at last we are getting V of t, that is AC square by 2 cos phi m of t plus AC square by 2 cos phi cos 4 pi fct plus phi into m of t. So just see the first term in this equation is the message signal, which can be extracted through low pass filter. So the output of the low pass filter will be the demodulator output or the message signal, which is AC square by 2 cos phi m of t. Here phi denotes what? If the demodulated signal, the amplitude is maximum, when it will be maximum? When phi equal to 0 degree. Okay, that's why the local oscillator signal and the carrier signal should have a phase difference of phi. Next, if the phi value is minimum amplitude, having minimum amplitude, that is phi equal to plus 90 degree or minus 90 degree, that time the output is minimum amplitude or the amplitude will be 0. So this effect is known as quadrature null effect. Okay, next type is Costas loop. So here both the carrier signal which are used in modulation will be used here also in the demodulation also, but with a phase difference. Okay, so see the block diagram here. So here two product modulator is used for upper one and lower one, and there will be an carrier signal which will be given through VCO, that is voltage controlled oscillator, with a which gives the carrier signal to upper product modulator and the 90-degree phase shift to the lower product modulator. Then this product modulator output will be passed to the low pass filter, and it will gives the output of demodulated signal. So just see the explanation here. So Costas loop consists of two product modulator with common input S of t, which is DSB-SC wave. Now the other input of the product modulator is taken from VCO, that is voltage control oscillator, with minus 90-degree phase shift to one of the product modulator as shown in the figure. Now S of t value we know, VCO output is what? For the first one is C1 of t equal to what? There will be an phi difference, that is phase difference, that is cos 2 pi fct plus phi. So the upper product modulator output is what? V1 of t, that is S of t into VCC1 of t. So putting the value here, so at last we are getting V1 of t equal to AC by 2 cos phi m of t plus AC by 2 cos 4 pi fct plus phi into m of t. So when it pass through this, when this signal is passed through the low pass filter, it will pass and it will give the low frequency signal, which is V0 1 of t equal to AC by 2 cos phi m of t. So next what? Next we will be giving the carrier signal, that is minus 90-degree phase shift to the second product modulator. So at last, after getting the input signal of DSB-SC, so the product modulator will be giving an output that is called V2 of t equal to S of t into C2 of t. So putting the values here, at last we are getting V2 of t equal to AC by 2 sine phi into m of t plus AC by 2 sine 4 pi fct plus phi m of t. So passing the value to the low pass filter. So at last the output of the lower low pass filter is V0 2 of t equal to AC by 2 sine phi m of t. So these are the two output we are getting after passing through low pass filter. Next is what? This output of these two low pass filter are applied as an input to the phase discriminator. So what is the meaning of phase discriminator? So phase discriminator will discriminate between the two phase of the signal. Okay, two phase difference of the signal. So that is will produce a DC signal or DC control signal, that is the pure message signal. Okay, now this signal is applied as an input to the VCO to correct the phase error. If any difference or any phase is in phase difference will be there, so it will be passing to the VCO for phase correction. Okay, therefore the carrier signal and the local generator signal are in phase. So this is about the demodulation of Costas process. So this is all about the demodulation of double sideband suppressed carrier.